Okay, so welcome to yet another revision stream. Okay, so I actually got a comment on the last one of these streams asking me, like, what exam paper is it? It is biology for AQA. We have an AS exam this year for biology, so what I'm doing is every week I'm going to try and do a couple of revision streams, maybe like 2 or 3, where I cover different topics. And today we're going to be covering movement across cell membranes, because we have an exam for it tomorrow. Like, we have a mock exam, which all the questions will consist of what is shown behind me here. So we have simple diffusion and facilitated diffusion, osmosis, active transport, and co-transport. Now, I have done a handful of past paper questions, I should say. And I'll be honest, they're quite nice. Some of them are very nice questions. Really, if you just know this stuff here, which I'll go through in just a sec, you should be good. So, you have simple diffusion, which is where a lipid-soluble, small molecule, and a non-polar molecule, it has to be all three, it's where one of those travels down a concentration gradient through the cell membrane. So a concentration gradient is basically from an area of high concentration to low concentration, so it goes down. Now, facilitated diffusion involves a carrier or channel protein, and that is for non-lipid soluble, non-small, so big, and polar molecules. Still going down the concentration gradient there. Osmosis is just diffusion, but replace the word, I guess, like concentration with water potential, down a water potential gradient. Active transport is diffusion, but reverse. It requires energy and ATP, and this allows it to travel against the concentration gradient. And co-transport involves two substances, and it often involves different types of transport, like active transport and diffusion. So a good example of this is, it also often uses a symporter or something like that, basically like a channel protein, a carrier protein. But co-transport, a good example, is glucose and sodium going in and out of the ileum of the small intestine. That's a good example there. And yeah, that's about it. Active transport always requires a carrier protein. I guess I should have specified that. And this is the structure of a cell membrane, a phospholipid bilayer. You have your phospholipid, which is a hydrophilic head, hydrophobic tail. You have your glycoproteins and lipids for recognition. You have your cholesterol, which reduces rigidity, which is useful because we don't have cell walls, so it's useful to have these in non-plant organisms. And then also, obviously, the channel proteins, which allow, obviously, as I've said, non-lipid soluble, big, polar molecules to travel through. Now, let me just try and think of some more information off the top of my head. I believe it's the tertiary structure of a protein, which is affected by, I don't exactly know what context that's in. I'm sure it'll come to me in a minute. But I'm pretty sure when going through a carrier protein, the carrier protein affects the tertiary structure of whatever it's carrying so that it is able to go through. Something like that. I may need to quickly recap that. But that's all I really can recall off the top of my head, to be honest. I know that ATP is obviously required for active transport. That's adenosine triphosphate. You have ATP, and you have ATPase, which is an enzyme which hydrolyzes the adenosine triphosphate. It breaks apart the unstable phosphate bonds, So you get an ADP molecule and an inorganic phosphate, which releases a lot of energy. Then you have ATP, I don't recall, it's ATP synthase, I believe. That's the enzyme that, I guess, joins it back together, joins the phosphate together via, I'm going to guess, a condensation reaction. But that's all. That's all I can really think off the top of my head there. So I guess we'll start with some past paper questions. And what we'll do is, because of the fact that I did a stream yesterday where I went through a couple, we'll repeat some of the questions that I did yesterday, but I'll be able to obviously explain them. So this question right here is, it's a model of a phospholipid bilayer, but a very old one. So it doesn't show any cholesterol, doesn't show any channel proteins, doesn't show any glycolipids or glycoproteins. It's literally just a layer of proteins on top of here and there. That's what the diagram shows. You guys can go on Physics Math Tutor and find this question yourself if you need to look at the diagram. But a thing I always say for biology that I always end up going against, like, silly, it's kind of silly, is sometimes you just need to be so obvious that, like, it's almost insulting. So here, on this diagram, all it shows are phospholipids and a layer of proteins. So it's asking you what differences that diagram has with the current model. You could literally say, oh, it doesn't have cholesterol. Oh, it doesn't have glycoproteins. You get marks for that. Literally just stating the absolute obvious is sometimes the best way to get marks. So here it says, give one similarity and two differences between the membrane structure shown in figure 2 and the fluid mosaic model of membrane structure. So you're literally just comparing them. That model over there doesn't have a cholesterol, and this model does. That model doesn't have a glycolipid, that one does. Like, literally just stating the obvious and you get marks. Then a similarity is that they both have a phospholipid bilayer. Next question. Name and describe 5 ways substances can move across the cell surface membrane. I mean, again, this is a 5-mark question right here. If we got this in an exam, I would be so happy. Because 5 marks for literally just stating all of these. I probably can't show there. And maybe that's better. Literally 5 marks for talking about simple diffusion, facilitated, osmosis, active transport, and co-transport. That is honestly the nicest 5 marks ever. Like, I mean, let's just think about this. Simple diffusion, you could just talk about the movement of lipid-soluble, small and non-polar molecules through the phospholipid, or I guess just the cell membrane, down a concentration gradient. Facilitated is for non-lipid soluble molecules going down a concentration gradient involving the use of a channel or carrier protein. Osmosis is the movement of water molecules down a water potential gradient. And I guess you could maybe specify that all of these are passive processes. Active transport is molecules going from an area of low concentration to high against a concentration gradient using ATP. And co-transport involves the movement of 2 molecules, or I guess 2 substances, against a concentration gradient using ATP involving a symporter. So you that might have sounded a bit like ramble, but all I did there for 5 marks, all I did was just state what simple diffusion is, what facilitated diffusion is, what osmosis is, and what these are. 5 marks. That is probably one of the nicest exam questions you could ever get. Literally for 5 marks, just saying, simply saying simple diffusion is down a concentration facilitated diffusion down a concentration gradient via a protein or carrier channel. You could also get marks for saying passive, which I said. So 5 marks there, and all you had to do was give the dictionary definitions of the topic. Lovely questions. Next one is figure 1 shows, okay, this one I didn't really understand before. The wording of this one is really shit, so it shows a cell from the lining of the ileum specialized for absorption of products of digestion. And then it shows a carrier protein found in the cell surface membrane that transports glucose and sodium ions into the cell. So obviously we're looking at co-transport there. I might draw a diagram quickly to look at co-transport. If I'm just drawing this off the top of my head here, but it's like you have your blood, and then you have the lining of the small intestine, and then you have, so what happens is sodium moves out via a sodium-potassium pump. That lowers the concentration gradient of sodium, so sodium then moves via active transport. Or is it diffusion? No, it's facilitated diffusion. Sodium then moves in via facilitated diffusion along with glucose. The glucose and sodium are then in the cell, and then that is when the cycle repeats with glucose diffusing out via facilitated diffusion, I think, or is it active transport? I don't know, but that's my rough memory of how it works. So the action of the carrier protein X in figure 1 is linked to a membrane-bound ATP hydrolase enzyme. Explain the function of ATP hydrolase. So that will obviously break apart the bonds between the phosphate molecules, or phosphate, I guess you could just say, which releases energy, which is then used to allow molecule, or I guess which is used to then go again. I hate having to explain shit. Without using sentences. Okay. Let me get a roll back on that. Explain the function of ATP hydrolase. It hydrolyzes the bonds between the phosphates. This releases energy, which is then used to allow molecules to go against the concentration gradient. Something like that, I want to say. I don't know. That is quite a vague question. Explain the function of ATP hydrolase. In what context? Is it asking me to explain the function of it in regard to what it's used for, or is it just asking me how it does it? Let's have a look. Explain the function of ATP hydrolase. It hydrolyzes the bonds, and yeah. So, okay, I would not have gotten any of that right, I don't think. You didn't have to mention hydrolysis, which is dumb, okay. Okay, see, this is the annoying thing. I hate how vague some of these questions are for biology. They are so vague and it is so annoying. What it was actually asking for was, what is a function, like, I don't even know what it was asking for. They barely scratched the surface there of it. What they were actually asking for was the function of ATP hydrolase is it turns ATP into ADP plus the inorganic phosphate, which I mean, I kind of said, I just said that it broke the bonds. And the energy produced in this reaction allows ions to move against concentration gradient. That is so nasty. Or you could say energy allows active transport. So I would have gotten a mark, maybe. I just hate how vague some of these questions are. Like, you have really nice questions that are like, oh, explain what these words mean. And then you have questions that are like, explain what this really specific thing is, but I won't tell you what context. Like, okay. The movement of sodium out of the cell allows the absorption of glucose into the cell lining of the ileum. Explain how. I don't understand this one either, because I thought that allows the absorption of glucose into the cell lining. So it's talking about going into the cell. The movement of sodium allows the absorption of glucose into the cell. I can't think. I literally cannot think off the top of my head here. I guess I could say... sodium moves into the bloodstream by a sodium-potassium pump. This creates a lower concentration of sodium. So sodium from the small intestine, the lining of the small intestine, travel via facilitated diffusion along with the glucose molecule. I don't know. Again, such vague, terminology. That one is really vague. It maintains a concentration gradient. It generates a lower concentration... Oh, hang on, I might have gotten a mark for that. A lower concentration gradient of sodium inside of a cell. So sodium moves in by facilitated diffusion. Oh, I might have gotten 2 marks for that then, out of 2. Sodium moves in by facilitated diffusion. I might have gotten 2 marks of that. That was so vague though, I did not like that at all. Describe and explain 2 features, what was that question? 2 features you would expect to find in a cell specialised for absorption. I've already wrote the answer to this one, kind of. If you have a folded membrane, that increases the surface area. A second one would probably be more mitochondria, because the more mitochondria you have, the more energy is released, which is used for active transport. That's going to be my answer. More ATP. Oh, and then I always forget this, but if you're talking about mitochondria producing energy, you should always just add via respiration, because for some reason they can be quite picky about that. Yeah, folded membrane, so large surface area. Large number of mitochondria to make more ATP. Okay, you would have had to be very specific there and say more mitochondria makes more ATP, because obviously there is ATP already being made. So more ATP is made by respiration. Okay, I think that one was fair. That was a fair question. I might have gotten a mark for that. Draw phospholipids on figure 2 to show how a carrier protein would fit into the cell's surface membrane. What the actual shit? That's a carrier protein? What the actual hell? Draw phospholipids to show how the carrier protein would fit into the cell's surface membrane. Well, you have hydrophilic regions and hydrophobic regions. So would it maybe be... I don't know. What the hell? Phospholipids position. Some of every head must extend into the hydrophilic region, and some of... Bruh. Oh, okay. No, that's so stupid. That is one of the worst questions I've ever seen. It's the most complex ass drawing of a cell surface membrane. Carrier protein. That is the most disgusting drawing I've ever seen in my life. You would have to draw phospholipids on that while making sure that they extend. Bruh, kill me now. I would not have gotten any of that. How many marks was that? 2 marks? Oh, go fuck off, bruh. The movement of substances across cell membranes is affected by membrane structure. Huh. That is a much crueler 5-mark question. The movement of substances across a membrane is affected. Okay, well, let me just jot down some notes here. I guess you could say the movement of... So, obviously the structure of a membrane... If the membrane is folded, that's a larger surface area, so a higher rate of absorption. If the membrane has cholesterol in, that makes the membrane more rigid. I don't know what effect that would have. I guess it would lower the rate of absorption, maybe. It's not talking about absorption, it's talking about the movement of substances. Oh no, it doesn't say increase or decrease. Okay, so I'm allowed to say that. I guess you could say channel and carrier proteins, they allow polar, or I guess you could just say they allow ions to travel through the cell surface membrane. I don't know what else you would put. This is a very weird one. That's a weird question, but I like that question. I don't mind it. All it's asking there is the movement of substances, which is a whole topic, is affected by the structure of the cell membrane. Explain how. So we know that obviously cholesterol does that. What other things could you talk about there? I guess you could talk about a phospholipid bilayer allowing lipid-soluble molecules to diffuse through via simple diffusion. That would be what I would put. Let's have a look. Here we go. Phospholipid bilayer allows diffusion of non-polar lipid-soluble substances. Boom, that is a nice mark. Phospholipid bilayer prevents diffusion of polar / Okay, so all I could have done there is expanded a little and said this means non... Okay. Carrier proteins allow active transport. Channel proteins allow for... Okay, I should have mentioned the processes here. I should have mentioned active transport and facilitated diffusion. Would I gotten a mark for anything else there? Shape of channel determines which substances move. I would not put that. The number of channels determines how much movement. I mean, that just makes sense. Membrane surface area determines how much diffusion or movement. Okay, so instead of saying high rate of absorption, you would have just had to say that the surface area affects, I guess, the rate of diffusion. Anything else? Cholesterol affects rigidity. Yeah, what did I put? Rigidity. Okay, so I wouldn't have had to put anything about lower. Okay, I might have gotten like 2 marks for that, which sounds bad, but it's because I missed out a lot of obvious details there. Obviously, I know that, channel protein are involved in facilitated diffusion, but I wouldn't have put that. I obviously know that phospholipid membranes don't allow ions through, but I didn't know I would have had to put that. So this is the thing with biology, which is so annoying, and what I despise about the mark schemes is you could understand a topic really well, but then having to actually put it into words is so annoying. And not only that, but then having to include obvious details is like even more annoying because you don't think of it. We'll skip that one because I've done it. Okay, this is such a shit question. I swear, this is one of the worst questions. It's a graph, and it shows the rate of diffusion, right? The rate of uptake. The rate of uptake, and then the concentration of a certain molecule. And one of them is like that, one of them is like that. And somehow from that, you would have had to interpret that means all of the channel proteins are occupied. This one means that diffusion is happening. Like, how would you have interpreted that from a straight line graph? I don't know. So I'm going to skip that one because we've already done it. It won't come up in the exam, but it's a nasty-ass question. Describe the method the student would have used to obtain results in the graph. Start after all cubes of potato have been cut and consider variables for 3 marks. Alright, that's just a practical we did the other day. You would have just had to state, when the potatoes are cut, add them to different concentrations of your sucrose solution, add it to a water bath at the same temperature, keep the volume of the solution the exact same, leave in for the exact same time, then you are measuring the weight. Alright, I guess you would say measure the initial mass and the mass after. Okay, I understand that one. It's just annoying to put into words. The loss of mass shown in the graph is due to osmosis. The rate of osmosis between 0 and 40 minutes is faster in B than A small q. Oh, okay. Is the rate of osmosis per millimeter squared different between A and B during this time? Well, I'm confused as to what it's asking me here. Between 0 and 40 minutes, is the rate of osmosis different between A and B? I'm so confused as to what it's asking me there. What is it cracking on about? Oh, and that is so bullshit for that question, by the way, the one I just did. So bullshit at all. You wouldn't have had to put an explanation for anything. You would have just had to say, keep it at room temperature, dry the cubes, put it in a sucrose, bruh. Me when I'm in a competition about stating the obvious. Okay. In mammals, in the early oh my god, what is this question? In the early stages of pregnancy, a developing embryo exchanges substances with its mother via cells in the lining of the uterus. At this stage, there is a high concentration of glycogen. Suggest and explain 2 ways the cell surface membranes may be adapted. Oh, that's a nice one. Just a large surface area by folding the membranes. This allows... Well, what would you say specifically here? Let's look. Membrane folded, so large surface area for fast diffusion. Okay, you would have to specify. Could you put large number of... you wouldn't have gotten it there for talking about mitochondria, which is what I put in the previous question. So that's a little bit goofy. You would have just had to say there's more protein channels for co-transport. Great. Smartest biology paper moment. Literally 2 identical questions with different mark schemes. Use your knowledge of transport across cell membranes to suggest how a carrier protein actively transports 1 sodium ion into the cell in exchange for a proton out of the cell. What the fuck? Co-transport hydrolyzes ATP. Sodium ion and proton bind to the protein. The protein... Okay, great. That is the thing I kind of was trying to talk about at the beginning there. Basically how the protein carrier the channel protein changes shape when it binds with the right molecules. And that's almost every question. High absorption of salt can result in higher than normal concentration of salt in blood plasma, which can lead to a buildup of tissue fluid. I don't know how that would be possible. I guess because less salt, because there's a higher concentration of salt in the, ileum, less is transported. I don't know. Higher salt. It's an osmosis question. Oh, piss off. I was talking about active transport. Higher salt is a lower water potential of the tissue fluid. Higher blood pressure. I love how we haven't even done that stuff yet, and it's asking us about it. Write an essay on the importance of diffusion in organisms. Great. For 25 marks. Compare and contrast the processes by which water and inorganic ions enter cells. That's a nice one. Contrast the processes of facilitated diffusion and active transport. Okay, that's a nice one. Just talking about the channel and carrier proteins. Explain the results shown in the figure, and it's basically... that's a nasty question, actually. And that's it. Okay. So that's all the revision I'm doing today, because I'm knackered. I cannot be asked. So in summary, I guess the best things to know for this exam, I don't even know. I feel like I've learned nothing from the last half an hour. The most important things to know, state the absolute obvious in an exam. Consider every type of movement across cell membranes for every question. Because obviously that one there, I thought it was about active transport, but obviously if salt's in our bloodstream, that's going to lower the water potential, so yeah, that makes sense. I really don't know how to feel about this. This is such a weird topic, because like a lot of it is stuff we've done before in the younger years that like is easy, but some of it is so irritating. Like, you know, transport. Like, I think co-transport and the whole idea of binding with a carrier protein to change the shape, and that uses ATP. I think that's probably going to be the most annoying part of the exam, talking about ATP, but I think apart from that, it should be okay. I mean, I can't think of anything else, really, apart from co-transport and channel proteins. Sorry, co-transport and carrier proteins. Those are like the only things that I really could struggle with. I don't think there is much else that could come up that would be really bad. So without further ado, I'm gonna go now. So good luck, and yeah, thanks for watching.